All right, we're going to review Chapter 10, Area. We'll jump right in, but before we get started, you might want to make sure that you have your formula sheet handy because we will reference that. All right, let's go. Number 1, we're going to look at the area here of a parallelogram. All right, so if you look at your sheet, the area of a parallelogram is the base times the height. Okay, now in a parallelogram, what you have to always remember is that the height is always the perpendicular height. So when I'm looking at what is the base, what is the height, the base is this measurement along here. The height is the perpendicular height here. They're giving us the 3.5. We don't need the 3.5. They're trying to mess with you. All right, so make sure that you know that your height has to be the perpendicular height. So then our base is 6. Our height is 3. All right, tell me what is the area. Okay, next problem, number 2. Oh, I guess I should finish that just in case you got it wrong. It was 18. All right, and it is centimeters squared. Okay, number 2. We've got the same thing. It's a parallelogram. So I'm going to use that same formula. The only thing that's different here is that the height measurement over here was inside the parallelogram. They've chosen to put the height on the outside of the parallelogram. Doesn't matter. All right, I'm actually going to let you do number 2 by yourself. Go ahead and I want you to get in the habit of writing some neat work. I'm going to be crazy picky on your test if you don't have work that justifies your answer. All right, so go ahead and do this one and then tell me what you get for your area. All right, you should have done the base times the height, 12 times 3.8. So you should have had an area measurement of, I got my calculator handy here. I got a 45.6. I think probably on our test, we will go ahead and round everything to the tenths place, but we want to be careful about rounding anything before the very end. We kind of keep all the decimal places until the end. Okay, let's move on past parallelograms. Let's try some trapezoids. And I haven't done like every type of problem. You might have a triangle. That's 1/2 base times height. All right, you have your formula sheet. Ideally, you can do a triangle. These are trapezoids. These might be new. All right, so you have area equals 1/2 the height times B1 plus B2. All right, that's your formula. So let's plug in everything that we know. Your area is equal to 1/2. Which number do you suppose would have to be the height? What would you put in right there for the height? All right, hopefully you chose 5. It's always the perpendicular height. And then your base 1 and your base 2, those are your parallel sides. So I'm going to have a 5.3 plus an 11.5. Let's go ahead and then I'll let you type that in your calculator. Tell me what your answer is. Even with the decimals and the fractions, this one still comes out nice to 42 feet squared. All right, so this is kind of what I'm looking for. At the very bare minimum, you've got to give me these 2 pieces of information on your test. If you just write 42, I'm counting that wrong. Show me that you know what your formula is, and then you can let your calculator do some work from there. All right, I'm going to let you do number 4 on your own. Let's figure out what the area of that trapezoid is. I got 28 centimeters squared. If you didn't, take a minute to pause the video and look at what you might have done wrong. You want to be sure that you're doing like inside those parentheses first, and then kind of typing stuff in your calculator from there. Let's go ahead and try something new. This one is a kite. A kite and a rhombus have the same area formula. The area formula is 1/2 the first diameter times the second diameter. I'm sorry, not diameter, diagonal. All right, I'm going to multiply the 2 diagonals. In a kite, you can see, well, even in a rhombus, the diagonals are not the same length. Now, sometimes they're going to hand you everything you want. Sometimes you're going to have to work for it. This diagonal right here seems pretty straightforward. It's going to have to be 20. All right, that part's easy. But I also have to figure out the other diagonal. And the problem that I have there is that they only gave me this as a 10. I don't know this one. So to get the total diagonal, I'm going to have to do some work. All right, so take a peek at this. They instead gave you this measurement over here. I don't really want that measurement, but it's going to help me find something because I know that's 26, that's 10. I'm looking for that measurement right there. Okay, why don't you answer the question on what would you be doing to find x? Hopefully you realize that's a Pythagorean theorem problem right there. So I know the hypotenuse and I know one of the legs. So you're going to have a little side note over here. And I want to kind of see your side note. I know we've done Pythagorean theorem a bunch. Maybe go ahead and just do this. 10 squared plus x squared equals 26 squared. At least let me know that you knew where the 26 went, because when I was grading these tests from chapter 8, I noticed a lot of us still getting it mixed up on where that c value, where that hypotenuse goes. So make sure you kind of show me that little side note, and then you do as much as you need to after that to figure out. If you tend to miss these problems, don't be lazy about showing the work so you don't make silly mistakes. I'm left with an x squared equals 576 because I subtracted the 10 squared to the other side. That happens to actually be a perfect square. If you do the square root of a 576, you probably don't know it off the top of your head, but it comes out nice. It's 24. So what you found then is that this 24 is this piece right here. And then if you add in the 10, you have a diagonal measurement of 34. Then we can put that in for the other diagonal. All right, go ahead and tell me what you get for area. Hey, did you use your brain and do some mental math? You could have done this in your head. Half of 20 is 10. 10 times 34 is 340 centimeters squared. All right, let's look at number 6. I said we maybe wouldn't do a triangle, but I thought I'd do one that was just a little bit weird looking. I don't want you to overthink this or make it harder than it needs to be. The area of a triangle formula is still 1/2 base height times height, even if you have this obtuse triangle. Now, this red 3.6 feet out here, that's not part of the triangle that I'm looking for. I am looking specifically for the area of this triangle. So that 3.6, I do need it, because if you look at it, it's that perpendicular height. But because my triangle is obtuse, it's out there on the outside, which happens a lot. All right, so you're going to put in a 1/2. Your base is just this 3 that's across the bottom here. That's your base. But your height is the perpendicular height that's over here, not the 6. Again, they're giving us extra information. They're tempting you to try to use something, but you don't have to use it. All right, go ahead and tell me what you got for the area. Finally, we have one that didn't come out perfect. It's still pretty darn nice, though. You end up at a 5.4 square feet. Okay, so again, the work that I'm showing here is kind of the work that I want to see from you. I want you to box in your final answers, because in a perfect world, I'm just going to scan through your test, see this beautiful work, and see all these correct answers boxed in. All right, let's keep moving. Let's spend some time on some harder problems here. These regular polygons. All right, to do the area of a regular polygon, I know that I'm going to use the 1/2 AP formula, but they usually give me some information, but not all the information that I need. So looking at this picture, they've drawn it a little bit sideways, but that's okay. This right here is that apothem measurement. It goes straight perpendicular to the side. That's the apothem. So when I'm doing 1/2 AP, I've got the A. But typically what we'll do is we'll go ahead and draw in to the radius there, and then you're looking at this triangle here. Now, you maybe have done enough of them that you know that is a special right triangle. A hexagon does give you a special right triangle. Remember what we did on this? Actually, let me get rid of those marks, and let's talk about how you know that's a special right triangle. Remember that we go 360 is all the way around, and then you're ultimately looking at how many of these triangles can I put in there. All right. And so since there's 6 sides, I'd have 6 of those. 360 divided by 6 is 60, sorry. But then when I drop that apothem right there, because right here, this full angle is a 60. But when I drop the apothem, now I'm only looking at the 30. Okay, so that's how I know it ends up being a 30, 60, 90. Now I'm going to like draw this off to the side because I think sometimes it gets too tiny and cluttery. So I've got my 30, 60, 90. Trust the picture. This is the short leg down here. Here's your short leg. I don't know what that is, but the apothem, I can't even read it anymore. What was the apothem? The apothem was 21. So it's this triangle here I'm drawing. Okay, apothem is 21. I need to know the perimeter, so that's going to be this side here that I want, so I'll find an X on that. Oh, I started off with a tough one, didn't I? All right, here's what you have to know from your 30, 60, 90. This is X, this is 2X, this is X root 3. Have you done this enough times that you know this yet? Your long leg is X root 3. If I want to go from the long leg to the short leg, I got to get rid of the root 3. So since it's being multiplied by root 3, I'm going to divide by root 3. I'm going to take my 21, my apothem, my long leg, and I am going to divide by root 3. And then we rationalize, and you're at 21 root 3 over 3. Oh, looky, 21 over 3. That would reduce. So we just found that little piece to be 7 root 3. All right, I think I started with one of the harder problems, didn't I? Okay, so 7 root 3. Let's look at what we just found there. The 7 root 3 is this short leg right here, which is in my triangle, this piece right here. And now what I'm looking for is the perimeter. The perimeter, I would have to take my 7 root 3 and double it to get this full side. So that'd be 14 root 3. And then I have 6 sides. So 14 root 3 times 6 is ultimately going to be, I'm just going to type in 14 times 6. Okay, so that's 84 root 3. That's for your perimeter. So one more time, you take this short leg, you have to double it to get that full length, and then take it times the number of sides. 14 root 3, double. Take it times 6. Okay, so now I'm ready. I got the information I need. Now I'm ready for my 1/2 AP. A equals 1/2 AP. Now let's see if you caught all the information we have. I got the 1/2. Okay, tell me, what are you going to put in for your A value? Okay, it should be 7 root 3 times. Now tell me, what are you going to put in for your P value? 84 root 3. All right, now we're going to go to our calculator. It did say to round to the nearest tenth, so let's go type this in our calculator. All right, when I type that all in, I end up with an area of 882. I guess I don't have any units on that one, so 882 is the area. Whew, that's a doozy, huh? All right, so now let's try another hexagon, because hexagons are pretty common. Now, they always create 30, 60, 90 triangles, but they oftentimes will tell us different things they'll tell us a different side of that 30, 60, 90. So let me go ahead and drop my apothem because that helps create the 30, 60, 90. Now this one I think is going to be a little bit easier for us because they gave us the hypotenuse. If you look back over here, the hypotenuse is the 2x, so I have to find my short leg and I have to find my long leg if the hypotenuse is 8. So let's take a minute. Let's answer a question on the EdPuzzle. What do you think the short leg would equal? What is the short leg? And what do you think the long leg would equal? Your short leg is half as long as the hypotenuse, so that would be 4. And then your long leg is the short leg times root 3. That's 4 root 3. All right, I think that's going to be all we need to find our area. Area is 1/2 AP. Okay, the apothem we have filled in, that's the 4 root 3. And the perimeter we could figure out because we know this little piece is 4, so we should be able to figure out the perimeter. All right, I'm going to let you finish this one out. Go find the area for me. All right, so here's what I ended up with. I put in the 4 root 3 for the A, for the apothem. The perimeter I ended up at 48. This is 4. The whole thing is 8. All the way around would then be 48 because there's 6 sides. When you multiply that all out, I kind of just do it all in one shot in my calculator and then round the answer there to 0.3. This is what I'd want to see for work. This got a little bit messy over here. This was a little bit uglier problem. I should have done that better. I apologize. But this is pretty, right? That's nice. That's what I want to see on your test. Can't get enough hexagons. Here we go. Here's another one. This time they're giving me the side length. On all 3 of these, I'm giving you something different, trying to help you work through what you do with that. So if I drop this, I might go ahead and drop the apothem and the hypotenuse of that 30, 60, 90 triangle right here. And if I recognize that the whole side length right here is 4 root 2, when I drop the apothem, this is going to be half of that. Half of 4 root 2 is 2 root 2. And that's the short leg in my 30, 60, 90. Oops. Right here I've got the short leg. So remembering that in a 30, 60, 90, the short leg is X. And then if I want to go bigger, which I'm going to have to, if I want the hypotenuse, I would double it. If I wanted the long leg, I would take it times root 3. Well, in this example, I want the long leg because that's going to be the apothem. Okay, so if I have to take the short leg and I have to multiply it by root 3, how long do you think this apothem would be? What would the apothem equal? All right, all you got to do is take your 2 root 2 and multiply it by a root 3. You actually can multiply those together. You get 2 root 6. So your apothem here is 2 root 6. All right, let's go through our area formula. Area equals 1/2. The apothem we just found was 2 root 6 times the perimeter. All right, let's work on that perimeter. This little chunk right here, well, really, I could just use this chunk. They told me the whole side is 4 root 2. And if I have 6 sides of that, 4 root 2 times 6 is 24 root 2. All right, why don't you figure out the area and answer the question? All right, hopefully you got a 83.1 when you type that all in. Let's look at one more. We're going to look at a triangle, but we're going to treat this like a regular polygon because they gave us the apothem rather than treating it like the 1/2 base height that we did earlier because they're not giving you like the base and the height. We're going to do 1/2 AP. It's an equilateral triangle. Now, since they already gave me the apothem here, that's 15, what I need to work on is the perimeter. If you will recall that in an equilateral triangle, we still get a 30, 60, 90, but it's laying over on its side. So when they give me the apothem here, it's actually the short leg. And I'll try to, it's kind of important that you have a nice, accurate looking picture because otherwise you kind of lose track of which side's the short side and which side's the long side. So be careful if you're drawing pictures to try to make it look accurate. So if I already know the short leg, then I can find the long leg. That would just be multiplied by root 3. I could also find the hypotenuse, but I don't think I'm going to need that, so I won't clutter that up. All right, so A equals 1/2 the apothem times the perimeter. Okay, why don't you answer for me the question, what do you think the perimeter is going to be on this one? All right, what you should have had is the 15 root 3. We've done this every one of these, where you have to take the 15 root 3 and you have to double it. So that's 30 root 3 times 3, 90 root 3. All right, let's type it in your calculator. Tell me what you get for your area measurement to the nearest tenth. This is what I got on mine. Hopefully you did as well when you type that all in your calculator. All right, got a couple more equilateral triangles. I'm just giving you different information on them, but on every one of them, you're going to draw this apothem and this radius, and it's going to give you that long 30, 60, 90 triangle. So in this example, it looks like I knew that the entire side was 10, so this side would be a 5. That would be your long leg. Oh, this is going to be one of those challenging ones. If the long leg in a 30, 60, 90, remember x, 2x, x root 3. The long leg, if I want to get to the short leg here, I have to divide by root 3. So I have to take a 5 and I have to divide it by a root 3. That's not very pretty. This is going to find my short leg. So the short leg is 5 root 3 over 3. The short leg is right here, which is also going to be your apothem. All right, so as messy as it is, I kind of think I'm done though. I'm ready to jump in and do my formula. 1/2 the apothem times the perimeter. All right, let's see if we can figure out that perimeter. They told you that the entire side was 10, so the perimeter would have to be 30. All right, type that in your calculator. Tell me what you get. All right, when I typed it all in my calculator, I got a 43.3 for the area. All right, let's look at this next one. All right, this one I'm going to turn you loose on. I'm going to help you drop the apothem, but it looks like they gave you the hypotenuse here is 18. That's a little bit hard to tell because where the 18 is, where it falls when you draw your triangle, but the hypotenuse is 18. So think about your 30, 60, 90 right here. If you know the hypotenuse, how do you find the missing parts that you want? I'm going to let you finish this one out all on your own. I mean, you got a test coming up. All right, go find your area. All right, this is our last one with the special right triangles. Not everything's a 30, 60, 90. This one's a 45, 45, 90. If you drop the apothem in this one, you could create yourself a nice 45, 45, 90. They gave us the hypotenuse. All right, if you look at a 45, 45, 90, you have x, x, and x root 2. All right, so if they're telling you that the hypotenuse there is 10 root 2, what do you think these two legs would have to be? All right, to get from the hypotenuse to the short leg, you have to divide by root 2. That actually plays out beautifully, doesn't it? You divide by root 2 and the root 2's cancel. You should have gotten a 10 on that. Those two legs are 10. All right, now there's different ways to find the area of a square. I guess for what I have, I could go ahead and do, it's a regular polygon. I could do 1/2 AP. So 1/2, the apothem is 10. And then the perimeter is 10, double it is 20, times 4 is 80. So the perimeter is 80. And I'm going to do this one in my head. I'm not even going to ask you to do it. 1/2 of 10. Well, actually, let's do this. 10 times 80 is 800, and 1/2 of 800 is 400. All right, that'd be your area. All right. Now, I do want to show you, though, that you can do this. Like I did my 45, 45, 90. You could just do base times height on this, couldn't you? Because look at what would happen. This is 10, so the whole base is 20. The height is also 20. Base times height, 20 times 20. Oh, what do you know? That also equals 400. So once you get your 45, 45, 90 done, then you could use either way. All right, this is the end of it. We're doing through 15, and then we're stopping. On these problems, though, these are the ones that are not special right triangles. These are the ones that we're going to use SOHCAHTOA on. So if I do that, let's look at what would happen. Remember, this one's an octagon, so I would type in my calculator 360 divided by 8. Okay, that's a 45. So I would have all of these little triangles in here, and they would all have a central angle of 45. But what happens is I'm going to end up dropping the apothem, which would cut that 45 in half. This is the one that's a 22.5. Let me draw this picture just a little bit bigger. That might help us. This angle up here is 22.5. This entire length is 7, so just the short leg would be 3.5. Now, if I'm going to do 1/2 AP, I think I'm going to be able to figure out the perimeter because of the 7, but I need to know this apothem. So I'm going to put an X or an A or something here on this leg. Now, from that, you have to decide if you're going to do SOHCAHTOA on this because the angle is not pretty. Would you do sine, cosine, or tangent? If you're using this 22.5, look at the two sides you're dealing with. Sine, cosine, or tangent. From the 22.5, we have the opposite side, the 3.5, and we're looking for the adjacent side. Opposite and adjacent is tangent. We're going to do tangent of the angle, 22.5, is equal to opposite, which is 3.5, over adjacent, which is x. Okay, this is the one that takes a little bit more work because I'm going to do times x times x. So then I have x times the tangent of 22.5 equals 3.5. So I actually have to divide on this to get the x by itself. What do you get when you type this in your calculator? What will x equal? All right, when I typed that in, let me erase this because I know it starts to get cluttery. All right. Well, I thought I erased it. Okay. I got an 8.4497. I don't know. There's not a clean break, but remember, we don't want to round until the very end on that. Okay, so now I think I found, remember x, let's go back and make sure you understand what you just found. X is this long leg. It's the apothem. So it's this measurement right here. If you want to call it A so that you keep track of that better, you can sure do that instead of calling it an X. That's your apothem. So we know the apothem and our perimeter. If this side is 7 and I have 8 sides, then I could find the perimeter. So why don't you do this for me? Why don't you answer the question and tell me, what would your formula look like? You're going to write A equals, what does that formula there look like to solve this problem? All right, here's what I've got. Plugging in the apothem and what the perimeter should end up being. Multiply that all out. I end up at a 236.6. So this has a label, centimeters squared. There's my final answer. On your test, what I would expect to see is a SOHCAHTOA step over here. Sometimes when there's just a number in the denominator, there's not a whole lot other than typing it in your calculator. That's fine, but set it up at least for me. The work down here is a little bit optional, but I want to see what you got for that x value. All right, and then of course I want to see the formula written out and then your final answer. All right, let's do one more of these. This is our very last problem. Are you ready to be done? Okay, me too. It's a pentagon. That's going to work a little bit differently, but I do know that it's not going to be a special right triangle. So when I drop the hypotenuse or the radius and the apothem, it does create a right triangle, but it's not a special right triangle. So I'm going to go 360. I'm going to divide by 5 big triangles. So the central angle is 72. But when I drop the apothem, it turns into a 36. So right here, this angle up here is going to be a 36. The other thing that we know is that the perimeter is 30. All right, if you got 30, then there's 5 sides. Each side has to be 6. which means this little piece here would be half of that. It'd have to be 3. And then I'm looking for the apothem so that I can use that in my formula. I'll call it A this time. I'm looking for the apothem. So now we have to look at that and decide, are we going to do sine, cosine, or tangent? And I'll do this one instead of making you do it because it looks very similar to last time, right? Because you've got the opposite, and then you have the adjacent. That's another tangent problem. So let's set up our tangent problem. Tangent of 36 is equal to opposite over adjacent. And then again, you're going to have to multiply by that denominator to get rid of the fraction. So the a's drop. Then you're going to have a times the tangent of 36 equals 3. Divide by tangent of 36. Tell me what you get for your apothem measurement. My apothem is 4 point. Remember that you want to leave as many decimal places as you can at this stage. We'll come back and round at the very, very end. I'm going to go 4.129. That seems like a good break point on that decimal. All right. All right, let's do this type of a question for you again. What is this formula going to look like? What is it that you're going to write? And then go ahead and find your answer as well. Do both of those. All right, here's what I got as I finished up. Hopefully you got the same thing. Okay, thanks for working through this with me. Good luck on your test.